In this video, we are going to be looking at scalar quantities, or scalars for short. Scalars are physical quantities which have magnitude only or numerical value but no direction. That is to say, we can describe scalar quantities based on their magnitude or size without taking into consideration their directions. Examples of scalar quantities are mass, length, time, distance, temperature, speed, volume, density, area, and so on and so forth. Now, addition of scalar quantities. We can add scalar quantities by simply adding their values together. For example, we can add 20 meters plus 30 meters, that is a distance of 20 meters plus a distance of 30 meters. That will give us a distance of 50 meters because distance is a scalar quantity. Also, we can add a temperature of 250 degrees centigrade and a temperature of 100 degrees centigrade. That will simply give us 350 degrees centigrade. So when adding scalar quantities, you just add the amounts together to give the sum of those quantities. Now let us quickly look at vector quantities. Vector quantities are quantities that can be described by their magnitude and direction. That is, they have both magnitude and directions. Examples of vector quantities are force, gravitational field, momentum, weight, velocity, acceleration and acceleration due to gravity, magnetic field strength, electric field strength, displacement, and acceleration, among others. Vector representation or representation of vector. A vector is represented in both magnitude and direction by a straight line with an arrowhead at one end of the straight line showing the direction of the vector. Now the length of the line represents the magnitude of the vector, while the arrowhead represents the direction or sense of the vector. Now you can see these examples here. I have a vector AB of length of 10 units, of magnitude 10 units. So it is represented by a line of 10 units, and the direction you can see is pointing in the easternward direction. Addition of vector. Now, if we have two vectors B and D moving in the same direction, and the magnitude of both vectors are 10 Newton and 12 Newton respectively, then we can find their resultant by drawing vector diagrams. Now, we are not given the directions that the vectors were going, but we are told that we are going in the same direction. Now, if we assume that both the 10 Newton and 12 Newton vectors are moving in the eastern direction, then their resultant is going to be equal to 10 plus 12, which is equal to 22 Newton in the direction of both vectors, because they move in the same direction. This can be synonymous, or this can be compared to two persons trying to drag a table. We have two people who are trying to drag a table. If they drag the table in the same direction, then they are going to move the table in the same direction they are pulling the table. 2. If vector B and D are now in the opposite direction, then we are going to have vector B, or the resultant, is D minus B. The reason being that D is of greater magnitude. So I'm going to have D is 12 Newton and B is 10 Newton. So the subtraction of 10 from 12 gives us 2, and the vector will be in the direction of D, which is the larger force. Now let's take these examples. Given that a 4 Newton force F1 travels from west to east, and 25 Newton force F2 travels in the opposite direction to that of the 40 Newton force, find the resultant of the two forces. So we get this. Now we are going to draw the diagram for the vectors. Now we see that the 40 Newton travels from west to east, that is from left to right, and the 25 Newton force travels in the opposite direction. Then it therefore means that the 25 Newton force will travel from east to west. Now by convection, when we move from left to right, we move in a positive direction, and we move from right to left, we move in the negative direction. So the 40 Newton force is assumed to be positive, while the 25 Newton force is assumed to be negative. So 40 minus 25 is going to give us 15 Newton. This means that the resultant of the vector is 15 Newton in the direction of the 40 Newton force. Now, if we have a 90 Newton force traveling from east to west, and we have a 35 Newton force traveling in the direction that is also opposite to that of the 90 Newton force, the force will be equal to, or the resultant force will be equal to 35 minus 90, because we assign negative sign for the force that moves in the left direction or the western direction, and we assign positive force for the 30 Newton force, which is going from left to right. So 35 minus 90 is going to give us minus 55. This simply means that the resultant vector is in the direction of the 90 Newton force. Now, if two vectors are of equal magnitude and they are acting in opposite direction, then their resultant force is going to be equal to 0. Assume we have two vectors B and D of equal magnitude, 12 Newton, but acting in the opposite direction. Their resultant is simply 12 minus 12, which is equal to what? 0. Now, if we have two vectors that are inclined at 90 degrees to each other, that is, they are perpendicular to each other, we can find their resultant using Pythagoras theorem. The length of the hypotenuse will represent the magnitude or size of the resultant vector. Now, take a look at this. We have two vectors B and D. B is 12 Newton acting in the northern direction, and D is 12 Newton acting in the eastern direction. So the angle between the two vectors B and D is 90 degrees. That is, they are at right angle. So what you do is draw a complete right angle, showing that the side opposite to B has the same magnitude as B, which is 10 Newton, and the side opposite to D also has the same magnitude as D, which is 12 Newton. Now, to get the resultant arrow, we apply Pythagoras theorem. So by using Pythagoras theorem, we know that the hypotenuse squared the hypotenuse squared is equal to the sum of the square of the remaining two sides. So we are going to have r squared equals b squared plus d squared, and r squared equals 10 squared plus 12 squared. R squared is equal to the square of 10 is 100 plus the square of 12 is 144. So r squared will give us 100 plus 144. That will give us 244. So to find r, we take the square root of both sides. So r equals 15.6 Newton. Now that is the magnitude of the resultant. So we have to look for the angle or the direction of the resultant. So by doing that, we are going to apply Scalar Quantities. Now if you take a look at the diagram, this diagram, you will find out that the side that is opposite to B is also 10 Newton. So that side is opposite to angle theta. Angle theta is the direction of the resultant, and we have D, which is 12 Newton. So by applying Scalar Quantities, tan theta is opposite over adjacent. That will give us 10 over 12. So that is what we have here. We have 10 over 12. So 10 divided by 12 equals 0.833. So to get theta, theta is equal to arctan 0.833, and that will give us 39.8 degrees. So what this simply means, if you go back to the diagram, you will see that theta is the angle that the resultant arrow makes with the vector D. So it therefore means that the magnitude of the resultant arrow is 15.6 Newton with an angle which is equal to 39.8 degrees to vector D. So that is the resultant of those two vectors. Now we can also find resultant by scale drawing, but in this section we will not be doing that. So we are going to do that in our next session. So what's the definition of the resultant vector? The resultant vector is a single vector which will have the same effect in magnitude and direction as the original vectors acting together. So if I have two or more vectors acting together at a point, the effect that they will have in both magnitude and direction is known as the resultant vector. Now the parallelogram law of vectors. The parallelogram law of vectors states that if two vectors acting at a point are represented in magnitude and direction by the sides of a parallelogram drawn from their point, that is the common point of action of the vectors, their resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from that point. Now this is vector B and D represented by the sides of a parallelogram OB and OD. All we need to do is to complete the parallelogram by drawing BE parallel to OD and DE parallel to OB. So you draw a straight line that starts from O and ends at E. That represents the resultant of vector OB and OD. Now if B and D are inclined at an angle that is not 90 degrees, let's say for example 60 degrees, we can now find the resultant either by using scale drawing or by using the cosine rule. But like I've said earlier, in this class we are not going to be using the scale method, but we are using trigonometry ratios, or we are using trigonometry. Now let's take this example. If two vectors of magnitude 4 units and 5 units inclined at 60 degrees act on an object at a point O, find their resultant. So to find the resultant, we are going to use the parallelogram law. So this is the vectors drawn using the adjacent sides of a parallelogram. So I have vector OB is 4 units and vector OD is 5 units. To get the resultant is OE. So by applying the cosine rule, we have r squared equals OB squared plus OD squared plus 2 times OB times OD cos 60 degrees. So to apply the cosine rule, this cosine rule you apply here is a little bit different from the normal cosine you use in mathematics. In place of minus 2 OB times OD, we replace it with a plus, because the cosine is actually the cosine of the angles between the two vectors. So if you take a look at the diagram, you'll find out that the angle between the two vectors OB and OD is 60 degrees. So to apply Pythagoras theorem to get r is going to be equal to, or r squared is going to be equal to OB squared. That's what we have here. OB squared plus OD squared plus 2 times OB times OD cos 60 cos the angle between the two vectors. So if you work that out, I'm going to have r squared equals 4 squared plus 5 squared plus 2 times 4 times 5 times cos 60 degrees. So that will give us r squared equals 4 squared is 60 plus 5 squared is 25 plus 2 times 4 times 5 is 20 times cos 60 degrees. So r squared is equal to 16 plus 25 is equal to 41 plus 40 times cos 60 is 0.5. So 40 times 0.5 is 20. 20 plus 41 is equal to 61. So r is equal to 61 and r equals square root of 61, which is equal to 7.81 Newton. So the magnitude of the vector of the resultant vector of OB and OD, vectors OB and OD, equals 7.81 Newton. Now to get the direction, or the angle DOE, we are going to employ sine rule. So by applying sine rule, BD all over sine alpha equals r all over sine 60 degrees. Remember that 60 degrees is the angle between the vector. So to get the angle that the resultant makes with OD, which is alpha, what you simply do is to find the opposite of angle alpha. The side opposite to angle alpha is DE. So you take DE all over sine alpha equals the resultant, which is r, divided by the sine of the angle between the two vectors, and the angle between the two vectors is 60 degrees. You can see from here that the angle between the two vectors is 60 degrees. So to get the result at the direction, you simply take the opposite side divided by the sine of the angle between the resultant and OD, that will be equal to the resultant all over the sine of the angle between the vectors. So that will give us 4 over sine alpha equals 7.81 over sine 60 degrees. 7.81 is the magnitude of the resultant. So we have 4 over sine alpha equals 7.81. Sine 60 degrees is 0.866. So when we cross multiply, we are going to have 4 times 0.866 equals 7.81 sine alpha. And 4 times 0.866 is equal to 3.464, which is equal to 7.81 sine alpha. So So we are going to divide both sides by 7.81. So on divided by 7.81, we have 3.464 divided by 7.81 equals to sine alpha. So on dividing 3.464 by 7.81, we get 0.4435. Now to get alpha,